All right, guys, moving along. I'm going to kind of pause, slow down, because I know some of this algebra has kind of thrown some of you for a loop. Some of you have got it, you've nailed it. And I'm trying to get some feedback back to you on those few problems at the end. Um, so that's kind of where we are today. So I'm going to kind of try to have some concerns, address some concerns for the problems that we've done. The ones from Wednesday, I believe it looked like this from Wednesday. Number one was A plus 1 over A plus 1 over A. Okay? A, yeah, lots of A's. So, like I said before, you have to start at the bottom when you have all of these fractions. Because we can't start here with this A and add it to this, because this is a big jumbled mess in itself. It's too complicated to simplify first. Okay? So let's start in the bottom part. Okay? So when you have A plus 1 over A, can you start there? Can you add those two fractions together? Now, what I do expect of you guys is to remember how to add fractions, how to get common denominators. You have to know those things, okay? So I'm taking this piece, and I'm going to get a common denominator that is A. The piece on the right is not changing, 1 over A. Okay, but this on the left, the A, how do I get a common denominator? Because its denominator is 1. So how do I get A as a denominator? Well, I have to multiply by A over A. Okay, so A over A times A over 1 gives me A squared over 1. Okay, now I really like to rewrite them because it keeps it in line. You don't miss an addition sign. You don't miss things happening. So this is going to turn into A plus 1 over, and now this fraction that was in red is A squared plus 1 over A. Okay? Now, what do? Can we add A over 1 plus 1 over another fraction? No, we have to simplify this fraction first. Okay, it's 1 divided by this other piece. Okay, so big deal, it's not 1 over A squared plus 1 over A over 1. That 1 is not there. Okay, that's not your complex fraction. It really is 1 over 1 times, okay, divided by this. So here, what do? Well, we divide fractions. 1 over 1 times. We keep, change, flip. So we're keeping our 1 over 1 times, and then we're going to flip the other part, A squared plus 1. 1 times anything is just going to be this. So this whole piece right here becomes A divided by A squared plus 1. Okay? I'm going to rewrite again because that's how I have to do it to keep it straight. Okay, now, if you can keep it straight and get everyone correct and not have to rewrite it, more power to you. I've been doing this a long time, and I still need to rewrite them to keep them straight. Okay, so if I replied to you and said, hey, on number 1 you did this, or on number 2 you did this, maybe it's okay to rewrite them. Take up more space on that piece of paper. It's okay. So here we go. I'm going to rewrite. So I have A over 1, I'm just taking that down, plus A over A squared plus 1. I have 2 fractions. They're both simple fractions, but they don't have common denominators. This one is just a 1, so this 1 needs to become whatever the other one is. So I need to multiply by A squared plus 1 over A squared plus 1. So that my denominator will be, that's it, A squared plus 1. Okay? So I'm just taking that denominator because I know it's going to be there. If you even want, I'll keep 2 fractions. So this fraction doesn't change. I'm just moving it over. Here, this A times A squared over 1 still must be distributed to both pieces. Okay, don't forget, just because it's on the front end of that parentheses, that it shouldn't be distributed. It should. So a times a squared is a cubed. A times 1 is a. So now I have two fractions that now have a common denominator, a cubed plus a plus a. So I'm going to scroll down, and it's going to follow me down. So when I add the numerators together, because now they have the same denominator, I can add. That isn't a. That a looks like a 9. A cubed plus a plus a. Can I combine these two a's? Yes, I can. Now, some of you, I'm going to be done here, wanted to reduce. You cannot reduce unless there is the same piece in every single term. You have 4 terms. 3, 4. Okay? The fact that this right here is a 1 says I can't reduce anything. Nothing. Nothing can reduce unless it can reduce by every term. Now, what would have been great if that one was an A? Then there's an A in every term, and you can reduce by an A, and that's it. Okay? But there wasn't. So you can't reduce. It's all over. Okay? Okay, so let's try one more like this. Maybe I'll give it to you for today's work. I think number 2, for the most part, everybody got correct. But I will say x squared y over 1 plus m squared plus x over y. When you are adding fractions, can you just cancel those out? If you are multiplying, then yes. But adding has an entirely different set of rules. You cannot mark them out. You have to get common denominators. Common denominators means I'm multiplying the right fraction by the left fraction's denominator. Okay, so I've got to multiply by 1 plus m squared over 1 plus m squared. Okay, so my left fraction I've got to multiply by the right denominator. So I need to multiply by y over y. Okay? Now, this x squared y is just a one product. So when I multiply y times that, I'm not distributing. I'm simply just multiplying. Y times x squared times y, which means I can simplify to x squared y squared over. Now, I'm going to go ahead. Well, I'm not going to just yet. I'm going to leave it like this for now. But I'm going to change it in just a second. Now, this x, there's something that I have to distribute because there's something with a plus sign. Okay? And that's a 1. I think somebody thought it was an L. It's a 1. So x times 1 is x. X times m squared is xm squared. There's an addition sign in between there. Okay? Your rules of distributing. Okay? Y parentheses 1 plus m squared. Okay, now do I have the same denominator? I sure do. I'm going to go ahead and distribute that denominator to be a y plus ym squared over, well actually under. Now the top, can I combine anything? No, nothing has the exact term, so it simply is x squared y squared plus xm squared. You're done. You can't simplify. There's nothing that has a common term of anything. I mean, there's a y in 3 of the 5. There's an x in 3 of the 5. There's only an m in 2 of them. Okay, there's nothing that's in all 5 pieces. That was number 2 from Wednesday. Might as well keep going and do number 3 from Wednesday. Okay, I don't even remember. Yes, it was the fraction. Okay. Here we go. 4 minus 3 root 2 divided by 8 minus root 2. I think the most common thing that was missed in these was subtraction signs, and that I'm actually okay with. You've got the big idea. It was just a subtraction sign that you missed. So when we conjugate, we multiply by the opposite of whatever's in the denominator. So instead of 8 minus the square root of 2, we put 8 plus the square root of 2. And what you multiply the bottom with, you multiply the top with. Okay? So when you FOIL, 4 times 8 is 32. 4 times square root of 2 is 4 root 2. Now this one, 3 times 8 is 24, but a negative 3 times 8 is negative 24 root 2. And then negative 3 root 2 times 2, that becomes 3 times 2, which is 6. But it should be a negative 6. Okay? And then the denominator, 8 times 8 is 64. The middle pieces, negative 8 root 2 and a positive 8 root 2, are simply going to cancel. I hope we have that in our brain. Okay? And then the square root of 2 times the square root of 2 is simply 2, not 4, but 2, and it should be negative. Now somebody put a plus. Negative, positive becomes a negative. That's okay. I mean, big picture, all of this one was pretty good. Now, let's go ahead and combine. 32 minus 6, I think is 24. No, it's 26. Sorry. 26, and then a positive 4 root 2 minus 24 root 2 should be negative 20 root 2 divided by 62. Now, some of you stopped right there, and I'm okay with that. Not going to be too much worried about it. But if every term, do you see your 3 terms there, are divisible by the same number, then you need to reduce. Okay? Meaning, can you pull a 2 out of all of it? Can I divide 26 by 2, 20 divided by 2, and 62 divided by 2? Now, if you don't pull out of all of them, you didn't do it correctly. Okay? You must pull it out of every piece. Okay? So the answer should have been 13 minus 10 root 2 over 31. Okay? Take a 2 out of everything. Now, 13 and 31, I'm pretty sure nothing's going into anything of those. Okay? So, we'll see how I'm recording this before I see your Thursday problems. But, exponent rules should be, let's see. I may go ahead and just work one. Probably going to do just the first one. Well, let's do the first one from Thursday. Okay, so it should have been x raised to the a, y raised to the a plus b divided by x to the negative a over 2, y to the b minus 1. Okay? Exponent rules. When you're multiplying and they have a common base, then you add them. If you're dividing, we subtract the base. If they have the same base, you subtract the exponents. So really, I'm only looking at exponents here. So I'm going to say a minus whatever's in the denominator. Okay, a minus negative a over 2. I do agree it's going to be plus a positive, right? Don't forget that rule. And then I have to get common denominators. So my common denominator would be 2. So I have 2a over 2 plus a over 2, which becomes 3a over 2. So that is my x raised to that power. Okay, let's look at the y's. I'm only dividing, so I need to say a plus b, and I like parentheses, minus b minus 1. Okay? So when I pull out these parentheses, really the first ones don't matter, but this negative will distribute to everything inside the parentheses. So I've got minus b plus 1. So b minus b is 0. Those cancel. So now I have simply an a plus 1. So I have a y raised to the a plus 1. Should these be multiplied together? Yes, they should. It should be one big answer. Okay? All right, now let's do one with square roots and fractions. I think this was number 3 from Thursday. So here we go. The square root of xy times x to the 2/3 times y to the -3/2. All right. So here we go. I'm going to rewrite first. I might even put the x's beside each other and the y's beside each other. It's okay to move them around. The commutative property lets us do that. So I'm going to have x raised to the 1/2, and then I'm going to have an x raised to the 2/3. Okay, then I'm going to take this y and have a y raised to the 1/2 and a y raised to the -3/2. Okay, then I'm going to deal pieces at a time. They have the same base, so what do we do when we're multiplying? We add the exponent. So what is 1/2 plus 2/3? I don't know, I've got to get some common denominators, right? So I need to multiply by 3/3 here and 2/2 here. So now I have 3/6 plus 4/6. And that should be what? X raised to the 7/6. Correct. Now what about my y's? They already have common denominators. I'm so happy. So now I'm going to add a -3/2. 1/2 plus a -3/2 is really minus. What's 1 minus 3? That is -2. So I've got a -2/2, which is a -1, right? So now I have a y to the -1, okay? We could stop there. If the instructions, which I didn't specify, it could be rewritten as x to the 7/6 divided by y. Either one of these answers would be sufficient. You are okay with either one. All right. I don't think we're going to do anything new. We will I need you to know how to reduce. Maybe I'll give you a few more problems for Monday, then we'll review and we'll have a small quiz just over some of these topics. Can you simplify? Can you reduce? Do you know what to do with exponents? Can you solve quadratics? We'll have a quiz on Wednesday, okay? So we'll do kind of a little review on Monday, give you some problems that are due Monday, and then we'll be done. I may even post it on Tuesday, so you've got Tuesday and Wednesday to work on it. That's what I'll probably do. All right, you guys are awesome. We'll talk to you later. Have a great